I'm quite blurred right now. It's getting better. So what is happening here is that the number of pixels making up the image are increasing, while the size of each individual pixel is decreasing, giving rise to a better video quality. So good that after a point we're tricked into believing that what we are seeing is a truly continuous video quality. Let's have a look at regular polygons, starting with a triangle, a square, a pentagon, a hexagon, a heptagon, and so on, increasing the number of sides. Doesn't it seem that if one were to construct an infinite-sided polygon, we would end up with a truly perfect circle? Infinity is the bridge between the rectilinear and the curvy. Using this principle, we can compute the area of as blobby an area you can imagine. Maybe you have a missile that is thrusting its way through the turbulent waters of the Atlantic Ocean. Here, the distance travelled by it will be the area under this curved velocity versus time graph, which can be modeled by some function f of x. We can try approximating the area using rectangles, whose area we know how to compute. Simply by looking at the animation, increasing the number of rectangles gets us closer and closer to the desired area. In fact, if we constructed infinitely many rectangles, each of an infinitesimal width, we would get the exact area. This area can be represented by this, where this term is the sum of the lengths of all the rectangles, the infinitely many rectangles, which is essentially the function evaluated at all the points between 0 and 1, times dx, the infinitesimal width. All we have to do to compute this infinite sum is to look at what value does the series of areas approach or get closer and closer to. What is the limit of the areas as the number of rectangles goes to infinity, which is, in this case, 1/3 or 0.333333.